Welcome back to the channel. Learn coding in 7 days.
If you just install the package here, you can become a pro coder fast.
Hi, I'm Larry Grenovich, and for years I told myself the same lie you might be telling yourself right now. I need to learn just one more thing before I can teach, before anyone will listen to me. One more modern language, one more framework, one more AI tool. Consume, consume, consume to learn enough. But you never learn enough. Never get enough experience. And by the time you get the experience, things have changed again. So you just keep consuming, constantly chasing that carrot of perfection. It is the classic consumption trap. I have been consuming to avoid creating, consuming to feel busy, consuming because there was just one more carrot, consuming out of a misplaced belief that many years of real-world experience weren't enough. I've used the same programming secret with every job I've had for the last 47 years to write code, often bug-free, and if there were bugs, I knew exactly where they were. And I always had comments from others that they understood my code. But I let the noise of life and the internet convince me I wasn't ready to share it. The secret I was taught at my first job that I've used ever since is not code or a language, but a system. I've reached the point that I have to stop and say, you've consumed enough. It is time for those struggling with programming to know the struggle is not code. It's not being taught the system to use to create the code. It's the most fundamental, powerful secret to writing software I've ever seen. It's been kept a secret by the elder programmers who only handed it down to worthy junior programmers. So it never made it into college, into formal programming communities, and it's long past time I share it. This is the single language agnostic system that separates the masters from the beginners. It is a no-code method for breaking down any project from a simple Python script to a complex enterprise system so that you write very little code, have almost no bugs, and know exactly where the problem is if one occurs. Let me give you an example of how powerful this system is. A few years ago, I took over a SQL project that someone had spent, I think, 60 to 80 hours on. It was almost done. It just needs a few more hours and a couple of features added to finish it. However, when I started asking questions, I found out the SQL had fundamental flaws. The query's purpose was to total time clock entries for payroll. The person who was almost done was asking the user to modify the SQL query in Microsoft Query Editor instead of passing in parameters, which was supported by the accounting software they were using. The nail in the coffin was their pay was every 2 weeks, and the program had decided to use Microsoft SQL's work weeks to handle the dates and pull the records. However, he never thought to ask when their pay week starts. And of course, it did not start on Sunday. It started on Thursday. And he had not yet figured out how to handle their paying time and a half for all hours worked on Saturdays and double time on Sundays, regardless of the number of hours the person worked during the week. And their California location has to pay time and a half for all hours worked over 8 hours in a day. And if a person worked over 12 hours in a day, they would get double time for those hours that they worked over 12. So the fastest way to fix the query was to rewrite the entire system from scratch, which in total took me 16 to 24 hours. While I was working through testing my totals with the client, mid-project, the client dropped a major system-level change on me. California, unlike Indiana, only pays time and a half on Saturday if you worked more than 40 hours, not including vacation and holiday hours. and Sundays are only double time if the employee worked 7 days straight. But because I wrote the SQL queries using this secret system, instead of starting over, I only had to copy a small section of code and make a code change of about 10 lines, and then spent a total of 4 hours to do it, including testing. Ultimately, we had some data come in that was different from what we were developing with, which caused 2 bugs, both of which were fixed in under 5 minutes and not more than 1 or 2 lines of code each. This is why I believe the current educational system is flawed. They throw you into the deep end with a specific language, tell you to somehow magically generalize the programming you did in this language to the whole field. They teach you the syntax before they teach you the thought process. Here's the truth. All programming's the same. The logic in a database query in SQL, the flow of a function in Python, the prompts you write for an AI are all governed by the same underlying problem-solving steps. The only thing that changes between languages is the grammar and the limitations of the language. The secret system was passed down to me by a master programmer because it was the only reliable way to produce quality work. It is a 3-part framework to solve the problem before the keyboard is even touched. I call it Group Flow Prove. So forget code, we're building a blueprint. So let's start with group. Master the data and the functions. This is where we decompose the project. For an invoice, you don't just write code. You define a customer data group, an item data group, and an invoice functionality groups. And any complex function you define then becomes a new lower level group that you can apply this entire 4-step process to. This ensures your project is always perfectly segmented and structured. So groups are data and functionality. Flow is every group of every set of groups is going to have a flow to it. And I define flow as the order of logic. This is a logic agnostic step-by-step definition of what your functions do and in what order. This flow will always contain the following parts: an input, processing steps, and an output. You've heard that before. It can often be represented by a flow chart, but it is not required. What is important is flow is your groups in processing order. For processing code, you would have as input the data group that is coming in, then the function groups that are doing the processing, and then the output data group. For an interactive screen, you define the open of the screen as input, because that's where you start, the independent objects, because everything these days is object events, and the completion events, like saving changes or canceling. This is what I call programming without code. The prove step. How are you going to prove that it works? Let me ask that question again. How are you going to prove that it works? This is the core of writing code without bugs. For every single group that you work with these subgroups to create, your question is, how do I prove this function worked? How do I prove the data passed into the function is right? How do I prove the data output of the function is right for all cases? You design the test into the group from the start and test each subgroup. This early testing eliminates most bugs, but most importantly, because your entire project is built from self-contained, verifiable groups, if something fails, you know exactly which group is the cause, because that functionality exists in only one place. The problem is localized, not lost in a sea of spaghetti code. And then to these 3 steps, and during the steps, after you get done with all the steps for a group, you need to apply something called simplify. So what you want to do is spend some time and reflect on how can I simplify this. So for instance, for an invoice screen, I might have a create invoice screen, I might have an edit invoice screen, I might have a delete invoice screen, I might have a view invoice screen. Well, I've got 4 different screens. Why don't I just write one screen and then write code to make it operate in the 4 different ways? That way, when I add a field one time to one screen, and it's automatically in all of the screens, and then I just modify the functionality for the things that make each of those screens different to make the screen operate differently. So let's so typically we would merge them into a single screen. All right. So for groups, can I combine some of the groups, or is the group too complex? Sometimes a single group, what you think of as a single group, is really a series of a very group of complex steps. And sometimes it's easier to break those down into subgroups so that you actually create more groups, because then you can follow the logic down through. And other times, things are so complex that they actually need to be their own group. So this is a group that does this, and this is a completely separate project where we're going to have subgroups inside of that showing the different functionality. It's going to have its own flow. It's going to have its own everything, because what needs to be done here for this step is so complex. So sometimes groups have subgroups off of them because they're just too complex, and you want to break everything down so that it's just silly simple. It's obvious how it works. For flows, there's always oftentimes a way to combine steps, or maybe you need to split steps. Maybe when you start going through the flow and building it out, you realize, oh, well, there's also, if it's this case, then the flow changes and it goes here. So since flows look like flowcharts, think about flowcharts. They a lot of times have multiple different ways things can flow through them. And then prove, you want to sit down and look at what you're trying to, you understand what you're trying to prove, but part of that is also defining your testing. And sometimes you can test multiple features with a single test. So sometimes you can take multiple steps of proof that you're trying to prove when you're making that list and combine those into a single step, because we know these 3 things are all going to be checked by this test. This test will not succeed unless all of these 3 things are true, or whatever it is. The secret to mastering programming is not to consume more. It's to internalize this framework. This is why I have been able to write complex back-end systems and even design prompts for AI, all with the same identical thought process. Are you ready to start programming and writing code with confidence? In the next video, we're going to start working through programming elements that all languages have, and then in additional videos, we'll move on to how to actually apply this structure that we're learning to actual code, while we group, flow, and prove to solve real business problems. Start learning how to program today, subscribe now, and let's get you building.